right, there we go. Okay, so what we're talking today is a difference of squares. The word difference means what kind of math? Subtraction. So your problem's going to have a minus sign in it. If it's a difference of squares, it's going to have a minus sign in it. And squares means a number that has been squared, right? So I'm going to wind up having to undo these problems. So if a number has been squared, I'm going to be looking for its square root. Okay? And once I find the square root, I'm going to pretty much be done with my problem. It's truly that straightforward. So if you look at these examples, these are examples of difference of square problems. Difference meaning the minus sign, and of squares, notice that these guys have square roots. What is the square root of an x squared? X. What is the square root of 64? 8. Pretty straightforward, right? What is the square root of a 4m squared? Not a 2, just a 2m. And 25 would be a perfect. 36g squared would be 6 with a g, and a 49 would be a perfect. It's pretty easy to find those answers, right? If you're not very good at this, and some people are not good at this, there's a button on your calculator you need to use, and it's called the square root button. See how it looks like a radical sign, a square root sign right there, that lime green right above the x squared? So you would hit the second button. There we go. Let's clear it out. Let's pick something bigger. Trying to think.
365.
How about 363? Yeah, let's try 363. Okay? Let's find the square root of 363. So second, well, okay, clear it. Okay, second square root button, which is the x squared lime green button. Okay? And then 363, and then hit equals. Oops, I guess it doesn't. Try 369. Let's try second square root 369. What one am I trying to think of? 365? Is that the one really? Okay. 365. That didn't work. Second. Yeah, and you could get a decimal, but we don't want those. It should turn, a square root's going to be a true number. Let's do one that I know we know, okay? Second square root 121. I don't know. Oops. That didn't right. Second square root 121 is 11. Okay? All of your answers should turn out to be whole numbers on this packet. You're not going to get decimals or anything like that, not with factoring, okay? Yes, sir. Yeah, 3 is a very common number. So, know that you're going to be looking for the square roots, and if you don't know what they are, use that square root button. So let's work this now. It says, factor the difference of squares. If you were given the problem, x squared minus 64, step 1, find the square root of each term. Okay, so I'm going to find the square root of the x squared, and then I'm going to find the square root of the 64. The square root of x squared is an x. The square root of 64 is an 8. You're good with that, right? Okay. Step 2, create 2 sets of parentheses. Notice they're exactly the same. We put the square root in each set of parentheses. So an x goes in each set of the parentheses, and then the 8 goes in each set of parentheses. So far, so good? Now think about what you have. How many terms were in this problem? 2. Okay, because there were only two terms in this problem, that middle term has collapsed out, right? What causes that to happen? One's a plus and one's a minus. They cancel each other out, and therefore the middle term disappears on you. And so when you build these, one's going to be positive, one's going to be negative. Now, will they be the same? Will the signs be the same? No. And now tell me why. There's no middle term. Okay, so when you look at your notes, this is an important part to have written down. If there's no middle term, you're going to have opposite signs. Was that okay? Yes, ma'am.
But I know, like,
Don't just ask it. I don't care.
okay.
We're good.
If it was like x to the third power,
Uh-huh.
would there be 3?
We're going to get to stuff like that. It's coming up, okay? It's a good question. But if it was x to the third power, you would need to look for the cubed root, and we are not far enough along in our algebra skills to do that. You might get to a cubed root in algebra 2, okay? But we are going to have some stuff where we have x to the 3, but we're going to be able to fix it. All right? That's a great question. So let's look at this, try it. So what are you going to do? What's the first thing? Find the square root of the first term. And so we would have a 5 with an n, right? Because we have the n squared also. So a 5n in each group. And then what's going to happen next? What's the square root? Would be a 9. And what will my symbols be? One's positive, one's negative. You finished your problem. Truly. Truly, that's all you do. Now, on B, B is a little bit unique. And B is actually going to be addressed down here. When I was typing this in, I shouldn't have. Let's cancel the 4 out. Let's pretend the 4 isn't there, okay? What am I going to do to this one? 2 sets of parentheses, and what's going to go in each one of them?
X.
An X. And what else? A 4. And my signs? One's a plus, one's a minus. Order doesn't matter. Doesn't matter which one you do first. Okay? How about the last set? A 6G is going to go into each set of parentheses. And the last term would be a 7. One's a plus, one's a minus. So, pardon me? I told you to cancel out the 4. It's gone. It's not there anymore.
Why didn't we cancel the 36G?
No, this was a typo.
Oh,
No, this was a typo. Okay?
so it's meant to be 1.
Yeah.
Okay.
Okay. All right. So can you imagine 12 of these problems going pretty quick? Right. So about half of your problems are like this. Now let's move to the next section. All right. Sometimes you wish it were a difference of squares, but it's not. We always need to look for a greatest common factor when we're doing factoring, no matter what type of problem it is. And so if we look at this example right here, 3c squared minus 75, it looks kind of like it could be a difference of squares, but there isn't a square root to 3 and there isn't a square root to 75. But could I factor something out and hopefully turn it into the difference of squares? Yes. 3 is the greatest common factor on this problem. So I'm going to put 3 out in front as the greatest common factor. And then when I divide by my greatest common factor, like we've been doing on these pages for the last couple of days, I would get a c squared, and 75 divided by 3 would give me a minus 25 right there. Now, is this set of parentheses a difference of squares? Yes. So now, this set of parentheses right here turns into the difference of squares parentheses right here. So the greatest common factor comes down, and I'm building my 2 sets of parentheses. Square root of c squared is c. Square root of 25 is 5. There were only 2 terms, so one's a plus and one's a minus. Do you see that? Let's try to do the try it right here. Pardon me? I can't hear you. I can't hear you. What do you mean? Could they be squared? Yes. I'm not understanding your question. Are you on the first problem or this one? A, try it A. Try it A. Okay. Is there a greatest common factor? We always want to remove the greatest common factor first. Even though the 4 could have a square root, we want to remove the greatest common factor first, okay? That's always your first step. So if we remove the greatest common factor of 4, that means we divide by that 4. Then I would get my answer of x squared minus a 4. You with me so far? Okay, now we look at it and think about it. Is this a difference of squares now? What's in the parentheses? Yeah, so now we're going to break that one set of parentheses into 2 and create our difference of squares. So the greatest common factor comes down, and now I'm going to break this part down into these guys. So an x, square root of x squared is an x. The square root of 4 is a 2. One's a plus, one's a minus. Alexis, does that answer your question? Okay. Yes, sir.
How can you tell if it's like a different set of but it's the same?
You have to know your multiplication tables and know what divides into what. You just have to analyze it. Yes, ma'am.
Wait, how did you get the 2s?
I took the square root of the 4 and the square root of the x squared. Okay?
Because it wasn't simplified.
Correct. Correct. Let's try the next one here. B. Is there a greatest common factor?
Yes.
They're all even, so I know 2 for sure. That it? Okay, so I'm going to divide by 2, and I'm going to get my answer. And this is the part I encourage you to write down on your assignment today. Many of my students try to skip this step. You will get confused and it'll take you longer. I promise. Just write this step. When you divide, write the answer in there. Do not do it in your head. Now, do you notice that it's a difference of squares? We've got the 4y squared and the 25. They both have square roots, so I keep going. So the greatest common factor comes down as a 2. And then I'm going to turn this part into a difference of squares. The square root of 4 is a 2, and the y squared is a y. The 25 is a 5. One's a plus, one's a minus. You finished your problem. So far, so good? All right. How about number 10? How about C? Greatest common factor is a 10, so I write the 10 down. I divide by 10 so I can get my answer to be correct. I would get a c squared minus a 1. Does 1 have a square root? Yes, sir.
So on B, you said 2 was the greatest common factor.
Yes, sir.
Were you talking about the exponent too?
No, exponent's never a common factor.
Where's the 2?
The 2 is the number that divides into both 8 and 50. That's a common factor. They both can be divided by that number.
Oh, okay.
So 10 can go into both of these, okay? You good? All right. So now I'm checking to see if this is a difference of squares. That has a square root. Does 1 have a square root?
Yeah.
Yeah, because 1 times 1 is 1. So yes, it has a square root as well. So we have a 10 as the greatest common factor. And then we do our difference of squares. One's going to be a plus 1. One's going to be a minus 1. So far, so good? Any questions before we move to the next step? Yes, sir. A, B, or C? Right here?
Yeah.
I'm dividing by the greatest common factor to get what goes in the parentheses. Okay? 10 would divide into both terms here, therefore it's the greatest common factor. To get the remaining, I divide by the 10, and that's what goes here. Yes, sir. Yeah, we're going to get to that. Okay? We're going to get to that. All right? Okay. Now, let's look at example 3. These are called perfect squared trinomials. So what do we know for sure that we have? 3 terms because it's a trinomial. Okay, this is where that shortcut comes in a little bit, if you were kind of good with it. Okay. Always look to see, step 1, is there a greatest common factor? Can 4, 12, and 9 be divided by anything that in common? 4 won't go into 9. Nothing, right? So that means I'm going to look at the first term, see if there's a real square root to the first term. I'm going to look at the last term to see if there's a square root on the last term. Do you see that both the first and the last term have square roots? We're going to build 2 sets of parentheses once again, just like we did on the other problems. Okay? So we're going to take the square root of the first term. So the square root of 4c squared is going to be a 2c and a 2c. The square root of 9 is a 3 and a 3. Notice you're still building identical sets of parentheses. Okay? But this time I need 3 terms to get my original problem. So are the signs going to be opposite this time? If they were opposite, I wouldn't have a middle term. So they're either both going to be negative or they're both going to be positive. Did you see any negatives in this problem? So they both have to be positive, right? Now, you can verify that the middle term would have turned out correctly if you remember the shortcut. Remember how we would take these 2 terms and multiply them together and then times it once again by 2 to get that middle term? Watch what happens. 3 times 2 is 6, so I really have a 6c. 6c times 2 is 12c. So it would make your middle term come back. If you were to FOIL this out to check your answer, you should get your original problem back. Okay? Yes, you can check all of your problems by working them back. If you FOILed these things and then turned around and multiplied by 4, you would get this answer back. That's the cool thing about factoring. You can check your work. There's no reason to miss anything. All right, so let's finish filling these out. Insert your operation signs. Will they be the same? Yes. Why? It has 3 terms. It has a middle term. All right, so let's see if we can do this one. Does the first term have a square root? Does the last term have a square root? Okay, I'm going to build my 2 identical sets of parentheses. The square root of x squared is x, goes in both sets of parentheses. The square root of 16 is a 4, goes in both sets of parentheses. Everything is positive, so I have positive signs. And if you wanted to write it to make people think you're super smart, you could write it like this. But this is technically your answer. If you were to FOIL this back together, you would get your original problem back. Yes, sir. Well, no, it's not trying to distract you. It's part of the problem. And if we FOIL this, we will get the 8 back. X times x is x squared. X times 4 is 4x. 4 times x is 4x. And 4 times 4 is 16. 4x plus 4x creates the 8x from the original problem. Okay. You don't do anything to it, but you could check it if you want to, if you don't trust yourself. Okay? How about try it B? Everybody seems to have a square root, first term, last term, right? Okay. Square root of 4 is a 2, and y squared would be a, so I have a 2y and a 2y. Square root of 81 is a 9. I do have a negative this time. It's going to have 2 negatives. And I can't hear you. Even if you have a positive, it'll still be a negative. What do you mean? Oh, yes, because a negative 9 times a negative 9 would create a positive 81. Okay? Yeah, all right? You see it now? All right. Real quick, on the back, your last 3 or 4 problems are like this, and this will answer somebody's question about, well, what about if I have an exponent of 3? Or something like that. If you remove a greatest common factor and it happens to be the variable, which it will be on several problems, it will turn into a 2 because you've divided. But there is a typo on this, so you may have seen that. We'll fix it in a second. So if we were to factor this, what would you start by doing? The C's. Remove the greatest common factor here is a C, so I'd put a C out here. I'm now going to divide by C everywhere. So now this becomes a 3C squared plus a 10C plus a 3, right? Now, this is a trinomial like we did yesterday. We're going to factor by grouping. So we have to do the A times the C. So we would have a 3 times a 3. So 3 times 3 is a 9. I need things that multiply to make a 9, but add to make a 10. So what am I looking at here? A 1 and a 9, right? Yeah, the first times the last. Yeah, A times C, okay? So now I have the 3C squared. I bring the first term down. I'm changing the 10C into a 1C plus a 9C. Okay? And then I bring the last term down. Now we can do factor by grouping, right? We have 4 terms. We just split them. What's the greatest common factor of this half? A C. And what will be left over when I divide by the C? 3C plus 1. What is the greatest common factor of the right-hand side? A 3. And when I divide by that greatest common factor, I will get a 3C plus 1. So my final answer, 3C plus 1 times C plus 3. And don't forget about the C that you took out at the very beginning of the day. Okay? So this is like the last 3 or 4 problems, like this. Now let's look at your packet and make a couple of typographical fixes. Yes, sir. Well, it's probably because you were absent. You need to watch the video. Huh? Yes? No? Okay. All right. On problem 8 on page 3, on problem 8, page 3, it should say 3n to the second power. And starting with number 8, start looking for a greatest common factor. So maybe you put a little star and put, look, GCF, because starting at that point, you're going to need to start looking for a greatest common factor on those problems. Then if you look at number 16, there should be a plus sign. It should be 4x squared plus 12x. Now, on problem 15, this is like example 3, starting in your notes. And then on problem 31, it should be 3m raised to the third power. And this is just like this problem we did on the back of your notes a couple of minutes ago. 3m to the third power. Okay? I know it seems like a lot of problems, but I promise they go super, super fast. Okay? Let me know if you need some help. And I'll post the video.